Nature offers many examples of tilings, repeating shapes that fit together like a jigsaw puzzle, like the hexagons on a beehive, or in a wasp nest, or scales of a lizard, eyes of insects. We created these tilings with simple code in Scratch. I painted one hexagon shape, used the code to repeat the shape over and over, tiling it. This pattern is so simple, you can rotate it 6 times and it looks the same. You can shift it over by one tile or up and down and it looks the same. By contrast, this tiling isn't quite so simple. You can see the kinds of symmetries it has. When you look here, you see there's a little line that has a curve and another line that has a little square embedded in it. It's based on a square, but you can turn it, as I show with code here, around 4 times each one of those patterns, and it creates this larger tessellation. So it has these 2 rotational symmetries, 2 different little shapes that rotate around 4 times. In that sense, it's like a square. So it's really 2 different kinds of rotational symmetries here, and each of those has a 4-fold symmetry because you can rotate it 4 times and the pattern looks the same. Now, let's look at how you create a tile like that. It doesn't have to look the same from left to right. It breaks that mirror symmetry into something more interesting, and you see how one side has a little curve in it and another one has a little sharp angle like a triangle, and they're essentially all squares, but you can fit them together to make either the squares, or if you rotate everything 270 degrees, it turns out, you get that other shape and they still fit together. No matter how many you line up next to each other, they'll always fit together like a jigsaw puzzle, which is called a tessellation. Here we did it with paper, made a little animation to show it. We cut out the little tiles and it works. It's a fun way to make this tessellation very concrete. How you get to symmetries, rotate around those 2 pieces you cut out 270 degrees, clockwise or counterclockwise. Now a simple square is the simplest kind of tessellation. It has mirror symmetry. You can shift it left or right, which is translational, or up and down. You can rotate it 4 times. It looks exactly the same. Plus, you can look at it in the mirror and it has the same symmetry. Now here I added a little square in the upper corner of each little square to make a point that if you rotate, you can see it. You can rotate 4 times and that little square will end up back where it started from. So you can change the orientation 4 times and the pattern looks the same. The overall pattern looks the same. That's true also of many other square-based tiles, like this little cross. We can make it easier to see the tiles by coloring it. And it's just a few lines of code to make all this work. If you copy this code in Scratch, you can do the same thing if you have the tile costumes. And here I'm just showing several different kinds. My favorite is this little bird-shaped tiling. It's based on an Escher design. MC Escher qualifies as art. And this puzzle piece, a simple square, all of them are based on a square and they have 4-fold symmetry. You can rotate them around each of 4 times, clockwise or counterclockwise, and it gives you the same overall pattern. And again, I added that little square in a corner to show that indeed it's turning. but still looks the same. That's what a symmetry is. You can change it, change the orientation, and yet you see the same pattern. Orientation you can change by standing on your head or lying on your side, essentially. Or you can move from left to right, and you see the same overall pattern. Moving from left to right or up or down is translational symmetry. It's just a term that they use. And rotating around is called rotational symmetry, or orientation changing, and you see the same pattern. So in the code, I just created these little buttons to make it easy to switch from one tile to another. You can watch this again to see all the code and try it yourself. This is my attempt to do interesting tiling in the Alhambra with paper and transparency. So I printed an Alhambra pattern. That's a pattern in the Palace of Granada called the Alhambra, one of hundreds of patterns there. And you see it has several kinds of symmetry. A six-fold symmetry, but also a three-fold symmetry and a two-fold symmetry. This does not have mirror symmetry. If you look in a mirror with this, the little points point the opposite way. That's what makes it interesting. Here we're showing translational symmetry. You can move it left to right over two tiles, up or down by one tile, and you see the same pattern. But the most interesting are the rotational symmetries. At one point, if you rotate around it, you can rotate it 6 times and you get the same pattern each time. Another one, you can rotate it just twice in the upper right there. And the other one in the lower right is a simple threefold symmetry. You can rotate around the center of one tile and you get the same pattern 3 times. Now here's a way you can make a hexagon-based tile. Each of these cuts we did with paper, and the cuts are all slightly different. It's the same process I showed with paper with a square, except with a hexagon. If you try this and then make a whole bunch of these tiles, they'll all fit together. And we cut these to be slightly similar, but not exactly, to look like a flower. And then we can put all these flowers together, and then first we paint a nice painting. My wife did this beautiful trillium flower based on the tiling we created. And then I pulled this little painting she did into Scratch and made it line up just like you would line up little hexagons. And they fit together. We made one green, one red, one white, so you could see the individual flowers. Then I added a little effect so that if you click one, the color change spreads out through the others, just for fun. Did the same thing with a very famous tile created by MC Escher. I just copied it and tiled it across like hexagons. And for fun, I added this little sound effect. Now here's how you draw an Escher tiling. Essentially there's these 3 shapes that you can represent as lines, and each rotates on a point, makes a little triangle. 3 out of the 6 points, corners of the hexagon. And when you rotate them around so that they meet at the other end, you have an interesting rotational symmetry that creates a little lizard shape. So I used Scratch to rotate these little shapes. Then I added a little, at the end, a little outline of the inside of a lizard pattern based on the MC Escher lizard tiling. Actually, he called it reptile. So you could create your own little lines like that and rotate them around, and you can make a tiling. You fit together all these shapes that you come up with, and it works, but you have to rotate the shapes around like a jigsaw puzzle. You can figure it out, it'll all fit together. Yeah, here's a pattern my wife painted based on the Escher. It shows that when you rotate the lizards around, they all fit together. See those little points of rotation I show with red dots? We have 6 lizards under the blue one. They rotate out and it fits together like the famous reptile Escher tiling. So remember, I had the 3 lines. That means it's a threefold symmetry. Now here's some wood tilings to show us how nicely they fit together. Same pattern.